Uyashaka. Hello. How's everyone doing? Hi. Low-key tired. Yeah. That cold weather kind of puts you in a mode of hibernation, right? I like the cold weather. I want it to get colder. I love the cold. Yeah. I want it to be by minus 50. Love the summertime. I like the summertime too, you know? I like the extremes. If it's going to be hot, I want it really hot. If it's going to be cold, I want it really cold. Nothing in the middle for me, man. So we're here. I'm pulling up 2.5 quadratic equations. Okay. Why would you want it either super cold or super hot? That's just kind of how I am. I'm a very extreme person, and because of that fact, I like extreme temperatures. But you know, when it's in between and it's a nice day, that's always cool too. But it's not a challenge to survive. I like the survival challenge. I like it to be really hard for survival so that it pushes me in my physical limits. But it's nice to get a break from the difficulties once in a while. Okay. Does anybody have any questions? Next week, so right here for our schedule, we'll be going over 2.5, 2.6, and 2.7, and a review for your first exam. Because if you guys look on your syllabus, take a look at your syllabus. You got your first exam is next week, September 14th through September 20th of that week. That's when you guys have your first exam. Let's see what time exactly. Let's go to here. Let's go to calendar. Yeah, exam 1 for you guys is due the 20th of this month. So you, yeah, not this coming Sunday, but next Sunday. So you guys are going to do that exam online. Do we come to school to do that? No, yeah, no, you got to do it online. Yeah. As much as I don't really find, you know, I think all this stuff that's going on in the world is kind of extra. As much as I think it's kind of extra, that's just the policies that the universities are upholding. So, no, we can't see each other in person. But we can always see each other virtually. I would like to be there in person while you're taking the exam, just in case you have any questions. You know, that's how it typically runs when all this crazy stuff isn't happening. But unfortunately, that is not something that we can do. at this time. That's not something I can do, very unfortunately. So you guys are going to have to ask me your questions now, okay? Then if the exam has some like stuff on it that is not fair or whatnot, then we'll discuss it, and I'll give back points if the questions are stupid or if they have dumb, finicky responses where you typed it in, you had the right answer, you just didn't type it in right and it counted the whole thing wrong. Yeah, I'm willing to go in there and give some partial credit to people in that sense. Makes sense? Does anybody else have any questions? You are very welcome, Jay. Okay. Nobody has any questions? So let's talk about 2.5, which is quadratic equations. Okay. All right. So recall we talked about quadratic equations being of the form ax squared plus bx plus c is equal to 0. All right. So now we're going to talk about various techniques to solving the quadratic equations. Okay. So let's say I have a quadratic equation, very simple quadratic equation, x squared minus 2x plus 1 is equal to 0. How can I solve for x? Okay, that is the question. I want to know what x produces this. Okay, now there's a multitude of different ways of doing this. You can use the quadratic equation, the quadratic formula. You can use completing the square. You can use direct check, like plug in a number for x and see if it equals 0. If it does, that was your x. That works to satisfy the equation. And there's also factoring, okay? All of these examples, all of these are techniques that we've learned on how to solve quadratic equations. And if you require more help after class, you can visit my YouTube channel, Professor Niazi, and it has me working out how to do completing the square, how to do quadratic formula, how to do solving it by factoring, and also how to graph quadratic functions and functions in general. All that information can be found on that YouTube channel. Okay, so let's do it by direct factoring this time. Notice that we can factor this like so. Since there's a 1 here, we can play that game where we ask ourselves, what's two numbers when we add them up, I get a -2, but multiply them to get a +1. And we realize that that's -1 and -1, right? Because whenever you distribute, you get x squared minus x plus 1. This is x squared minus 2x plus 1. Cha-chink. Now, you have been trained that once you factor this like so, and you set it equal to 0, you've been trained to know that you can set each of those pieces equal to 0, haven't you? You have been trained for that. People have taught you to do that. Okay, but they haven't told you why. So here's the why. Let's say I have two numbers, a times b, and I multiply them together and I get them to equal 0. What can I conclude about the numbers a and b? Well, the answer to that question is we can conclude three possibilities, three logical possibilities. Possibility number 1, A is equal to 0, okay? Which would mean 0 times B is equal to 0. That's why we get 0. Here's option 2. B is equal to 0, which would imply that I got A times 0, which is 0. Option 1, option 2. Then there's a third option, that they're both equal to 0. So actually implied here in these options number 1 and 2 was that A was 0, but B wasn't. B was 0, but A wasn't. But over here, they're both 0. And these are all logical possibilities. Given any of these possibilities, then our product of the two, A and B, is equal to 0. So consider this piece to be called A. Consider this piece to be called B. Now we got our A times B is equal to 0. That's why we can set each of these pieces equal to 0. Because logically, either this piece is 0 or this piece is 0, or they're both equal to 0. Logically, all of that is possible because their product is equal to 0. So algebraically, I can solve, this implies x is equal to 1. And so does this. Okay? So let's come up with a less non-trivial example. How about x squared plus 10x plus 21. Okay, and we set this equal to 0. I want to find what is x. What is x equal? Okay, we want to solve this quadratic equation. So what we can do is we can factor it. We can add, because there's a 1 in front of that x squared term, we can say that this must be there must be some number that when I add those two numbers, the pair of numbers, such that when I add those two numbers, I get 10. But when I multiply those two numbers, I get 21. Positive 3 and positive 7. That's right, Joseph. So that means we can factor it like that. And by this phenomena here, called the zero product rule, if A times B is equal to 0, maybe this is our A, this is our B. If A times B is equal to 0, logically we can conclude that either A is equal to 0, or B is equal to 0, or both. They're all logically possible. Okay? So that means X can equal negative 3. And furthermore, that implies that X can also equal a negative 7. Those are just logical possibilities. So this is solving quadratic equations using product rule, using factoring in the zero product rule. I'm sure before your teachers will just tell you set this piece equal to 0, set that piece equal to 0. But did they ever explain to you why? First of all, did they ever explain to you why you were doing that? No. No. Why didn't they do that? It's so simple of an explanation. Right? It is lame. It's very lame. They could have easily explained it to you. It's very simple. And this is the kind of stuff that would make me, growing up, not like math. I actually did not like math growing up. Math was my least favorite subject because my teachers wouldn't explain this stuff. And they're just asking me to take their word for it. And I don't ever do that. I don't ever take anyone's word for anything. I have to see for myself. That's just the kind of person I am. And so it would just really piss me off and make me really upset and it would make me hate that subject. Which is probably you guys. Who here had a similar experience? Who here had a similar experience with math? Not only did they not explain to you why you were doing what you were doing, but also if you ever questioned it, they would get upset at you. And they would also teach it in a way in which is confusing and doesn't make any sense. Who here would typically have gotten frustrated at math because of that? Yeah, definitely Carrie. Joseph, I just wouldn't go all the time. Yeah, basically everyone everywhere. I'd cry. Yeah, Carrie, I'm not gonna lie, not too proud to admit, but I too would cry too. I would cry out of anger and frustration because I wanted to slap all my teachers and I wanted to slap all my classmates as well. Yeah, yeah. Matter of fact, I would slap some of them and I would get in big trouble. I would get sent to the principal's office. Which would make me not like math even more. Yo, hated my classmates. Yeah, yeah, because if you ever asked a question that showed curiosity, or if you ever wanted justification, not everybody is cool with that. Some people are like, "Why are you asking more questions? Why are you why are you interested in this stuff? You're almost like lame and uncool because you actually have any type of like curiosity, right? Who here got ostracized by their colleagues in high school or whatnot just because they had interest in something academic, right? Who? Yeah, yeah. I'm getting a lot of people agreeing. Yeah, because we live in a culture that does not promote intellectualism. As much as I love sports and athletics, I love that stuff. I consider myself an athlete. I train every day. But as much as I like that stuff, our society was not built by muscle. This can only do so much. Our society was built by brains. Our society was built by minds. And we need to have more appreciation for intelligence and academics in our culture and in our society, in which we don't. So if any of you here got made fun of for being a nerd, just know that if I was your classmate and if a bully was messing with you, I'd beat the crap out of that bully because I was the nerd that protected the other nerds from the bullies. And now I'm going to protect you guys from your poor experiences of mathematics. Okay? I want to make sure you guys get a fair shot at understanding mathematics. Our hero, yeah. Mathletics, baby. What does that say? Yep, that's right. Hero of the nerds. Okay, so let's do one more example. Let's do 2x squared. No, actually, let's do x squared minus x minus 12 is equal to 0. So, what are two numbers that when you add them, you get -1, but multiply them to get -12? Close, Jay, because -3 plus a -4 gives me a -7. That's not a -1. But yeah, Albert, 3 and -4, yes, those add up to give me -1, and they multiply to give me a -12. Okay. Now let me segue on to one more discussion about making mistakes. Again, I have this issue with society. Not only do I not like society, that puts an overemphasis on athletics and an underemphasis on intelligence and academics. I don't like that because all of technology and all of society revolves around science and mathematics. And that's why we have air conditioning and rockets and airplanes and computers. But not only do I not like that, but I don't like the fact that our society likes to make people who make failure and mistakes seem like a horrible thing. Okay? Actually, guys, the people who are the most successful in life and the people who are most successful at math or anything else are the ones who made the most amount of mistakes and that learned the most out of those mistakes. You can't just make mistakes and mistakes and mistakes. Mistakes are only good when you learn from them. But you shouldn't be scared to make mistakes because if you don't make the mistake, you can't learn from it, okay? So in order to learn, you must make a mistake. So making a mistake is an essential process in learning, okay? But we all know people out there who make mistakes after mistakes after mistakes, and they never learn. So those people just make everybody else look bad because the truth is making mistakes is a natural process in trying to learn, okay? But you must learn from those mistakes. You must analyze yourself and think, what went wrong? I'm going to fix that, and I'm going to try and avoid that from happening. So to me, making mistakes is a wonderful opportunity to improve and learn. But to society, people think, oh, you messed up, you made an error, you're not good, you're this and that. Shut the freak up, society. Nobody cares about your gosh dang opinion. Over here in my class, making mistakes is a good thing. And learning from them is highly encouraged. And I'll teach you guys how to learn from your mistakes, okay? So I can factor this to a x minus 4 quantity and a x plus 3 quantity is equal to 0. So then we know that x minus 4 can be set equal to 0 because this is our a and this is our b. A times b logically implies that these are possibilities. This implies that x is equal to 4 and this implies that x is equal to negative 3. So these are our solutions to our quadratic equation. Okay? So that's how to solve by factoring. What if you got something like this? 2x squared minus 4x plus 8 is equal to 0. Well, now you don't have this being a 1, and that makes factoring more difficult. Why don't we introduce a new technique called completing the square? Okay, ax squared plus bx plus c is equal to 0. Okay, so this a right here is a 2. This b right here is a negative 4. This c right here is an 8. Completing the square says you get your b, you divide it by 2, and you square it. Then you add that piece to both sides of your equation, and you should be able to factor. And I'll show you what this means. This is the argument in general. Here's the argument in practice. Our b is a negative 4, right? So we get that negative 4 divided by 2 and square it. That's the first step. Again, I'm telling you, do this process, and I'm not explaining to you why, and it's bugging me. But completing the square has a geometrical proof to it, okay? It's a geometrical proof to it. It goes like this. It says that if this is A, right here, and this is B, so this is A plus B. So the area in here is A plus B quantity squared, right? If this is A plus B, and this is A plus B, inside, this is a plus b quantity squared, right? So you would get that this distance would form an a squared, and this distance would form a b squared, okay? So completing the square is really adding that last piece over there, okay? Because notice that when we complete the square here in general, this last added piece is this b squared over 4 when we add it to both sides, okay? None of this will be on the test, therefore I won't talk about it too much. If you guys want to see the derivation, I will derive it in a YouTube video. That is something that I can do that I haven't done yet, okay? But over here, let's go back to solving this problem. If we have some time left, I might derive it after the review. We'll see. So we go through here. So then I get my b, which is -4, divided by 2 and square it. So that's -2 squared, which is +4. Okay? That is the first step. Step 1 in completing the square. Get your b divided by 2 and square it. Okay? Step 2, you send the constant term packing. Oh my goodness. I forgot a step. This is really step 3, and this is really step 2. There was one step that I had not done yet. Okay. So let me show that step real quick. I jumped the gun here. So that's step number 2. Step number 1 is this, which is going to alter step number 2. So I need to actually delete it, and we'll start over here on the left. Step number 1 is to make sure that this number in front of the x squared is 1. Okay, so in order to make this number 1, I have to divide the whole equation, the left-hand side and the right-hand side, by 2. So that 2 over 2 equals 1. Okay, that's step 1. So I divide this whole thing by 2, divide this whole thing by 2. And I know you're wondering, why are we doing this stuff? Why is that step 1? This is just a technique. This is just how the technique of completing the square works. And again, guys, it's telling me, yeah, are you guys also getting that? We got 10 minutes. Yeah. Once it runs out, I'll just like create a new one and invite you guys all over again. That's really, really, really dumb. Okay, I'm just gonna have to work with what we got here. This 2 distributes to each of these terms. Look. And 0 divided by 2 is 0. You can't divide by 0, but you can divide 0 by 2. That's fine. You can't put 0 in the denominator, but 0 can go into the numerator. So notice that these 2's cancel. So I get this x squared minus 2x plus 4 is equal to 0. Now we can start our complete the square process. We get this b, which is -2, divided by 2, and square it. Okay, so then this becomes a -1 squared, which becomes a 1. So this is step 2. Complete the square. Step 3, add this constant term 4 over to the other side, and then add 1 to both sides of the equation. So I subtract both sides by 4, I send the constant term on the other side, and then I add 1 to both sides of the equation to get this. what's remarkable about completing the square is now we can factor this guy right here. It's very simple. Something that was difficult to factor initially is now become easy to factor over here. Something that we've already factored before. And this equals a -3. Okay? But what's great about this situation is something times itself can just be represented as that thing quantity squared, right? So what I can do is we can take the square root of both sides to solve for x. Oh my, I've invented a bad problem here because we're taking the square root of a negative number, okay? But we know how to do that, right? You won't get questions like this on your homework or your test because you usually have real valued answers. But you know what? That's okay. We know what the square root of -3 is. It's I root 3 from our complex analysis. And so this is equal to -1. The square root of a square is just x minus 1. Okay? So recall that this is going to be plus or minus. So that implies that my x is equal to 1 plus or minus I root 3. So one of my solutions is when I add, which I like to call x plus. So that implies I get 1 plus I root 3. And x minus, that's when I get 1 minus I square root of 3. Okay, so here's our two solutions. You usually won't get a situation where you get complex numbers, okay? You'll usually be given situations that you'll get real valued roots. But it's not that bad. We can still find them, okay? It's still practice. How much time do we have until it goes off? 3, oh yeah, 3 minutes, okay. Let's do another example. Let's do 3x squared minus 6x plus 17. And actually, let's say minus 17. And let's say this equals 0. Clearly, this is hard to factor. Okay? So let's use completing the square. Step 1, divide both sides by the leading coefficient, 3. This gives me x squared minus 2x minus 17 over 3. Because the 3 distributes to this, it cancels. The 3 distributes to this, I get a -2. And when the 3 distributes to this, I get a -17 over 3. And that's always set equal to 0 because 0 divided by 3 is 0. Step number 2. We complete the square and we send the constant term packing. So I'll send the constant term packing right away. And now I'll complete the square. I get -2 divided by 2 and we square it. So this becomes a -1 squared, which becomes a 1. This is the piece that I add to both sides of the equation. Okay. How much time do we got until it closes? 1 minute, 54 seconds. Okay. So now this, I can represent this on the left-hand side as this product. And this equals our 17 over 3 plus 1. Okay? But notice they don't have a common denominator. So 1 is really technically 1 over 1. So 1 over 1. So I have to multiply top and bottom by a fancy number 1, which is 3 over 3, to establish a common denominator. So then I get 17 over 3 plus 3 over 3, which is the same thing as 17 plus 3 all over 3, which is the same thing as 20 all over 3. And remember, that all equals my x minus 1 quantity squared. Okay? I'm going to hold up because it's about to like kick us out. So I'm going to leave and re-invite everybody. Okay, guys?